Okay, let's look at how we program in C++ or in C. So the initial thing we're going to do is use a text editor that is within what we call an integrated development environment, or an IDE, within which we're going to write code which will be labeled as our source code. Then we will, depending if we have any other library files to add to it, we will link them and compile the whole thing into an executable file, which will be the application. So at this stage, I am in the IDE dev C++. It's opened up, and I'm going to start a new file, which will be our first program. So I'm going to go over here and say File, New, and you could say Source File right here. So I'm going to click on that, and I get this IDE where I can type whatever I want, but that's not what I want to do. Well, what am I going to do here? I'm going to write our first C++ program. Okay? So to do that, you need to write this program in a procedural manner. So if you're reading your textbook, you're reading about functions, procedures, you need at minimum one procedure or one function called main. And typically, its technical name is called the controlling function. So, okay, so how do you write main? You do something like this. Main is a function. You open a curly brace and you close curly brace. That is the minimum requirement to have an actual function defined. Defined means I've already told it what it will do. A function, again, is a job, so it's supposed to do something. And this is the minimum requirement, actually, to have a C or C++ program. We will fix it up a little more than that. Notice that main as a function, notice the pattern and way it's written. You have these parentheses. So anytime you see these parentheses, you know it's a function. Some functions, you might see things inside of it, and those are called parameters. Okay? And then you see curly braces. You see an opening curly brace and a closing curly brace. Well, what happens in between is what we call the function definition, or what does the function do? And that's where you write your main code here for this function main. Now, for this one, if I actually save this file, so let me go ahead and save it, File, Save As. I'm going to go ahead and tell it to save it to a directory, and it will be my intro to programming. I'm going to just save it in here, and I'm going to call it example 1. And notice that the default way the compiler, or the IDE wants to save this is in .cpp. Keep it that way. Now, if you want a C program, then you will go to .c. So we will keep it at .cpp. I'm going to hit save, and here we are. Now, will this run? Okay, so the way to know if it's going to run, first of all, let me show you what's going on in that directory. So if I go to that directory, here's example 1, right? I have a source file, okay? And as you can see, it was created today at this time, if my clock and schedule is correct, all right? So now I'm going to do one more extra step, is I'm going to compile this, which means I'm going to take this source code and create another file out of it that the computer can actually execute, will be your application. So I'm going to go to Execute, Compile. And there you have it. So what I did here is I got a message that says it compiled, there were no issues, and everything was fine. There are no errors, no warnings. So I'm going to close this. Now let's go back to that directory and see what happened. As you can see now, I have 2 files. Okay? I have example 1, which is an application. So if I double click on it, it's just like a game or a word processor. It's just like any other application. Notice this one is 16 kilobytes. So it's a lot larger, right, than what we started with. Okay? Which is fine, because this includes a lot of other bytes in it that the computer needs to run just the program that we just created, even though our program does nothing. So if I double click on it, notice my screen just blinked. It actually executed. There was a process that the operating system handled and terminated once it was over. So let me just minimize this for a second. So can I run it from here as well? Yes, you can. So you can actually run it from here. As you can see, it's just blinked. So is there a way to hold the screen and hold the process so it doesn't die off and so on and so forth? Yeah, and we get to see that later on, depending how we want to control how the application runs at runtime. That means while the application is running. Right now, we're at the source code. So we want to do a few things here. This is a C++ program. I would like to be able to print to the screen some sort of a message maybe, right? So you're probably familiar with a lot of programming that you've taken before where you've done Hello World. If you've done it in C or in Java or in Python, you've had a print function somewhere, okay? So it's the same thing here, except to print to the screen, okay, we're going to need the help of an actual library file that we need to include in our program. So you must include IOStream. And notice we don't need a .h like in legacy C. So I need IOStream as a library file that has functions in there for me and utilities that I could use to print to a screen. Aha. Okay, can we use it? Sure. So if you're going to do that, then you could use the keyword cout, and you could orient to it a string, right? Or redirect a string to it to print out to the string. Now, one more thing I'm going to do, and then we'll cover this extra line of code some other time, once we understand what this means. So let me go ahead and do using, which we call a namespace. So we will worry about using namespace std as far as what does it mean really in the future. So let me just compile here just to make sure that my code is good, as you can see. So for now, you at least need these two at minimum. Okay, so what can we do? Now I could do something like this, cout, okay, hello world. And then end the line, end L, actually like this, okay? So this means end line. So what it's doing is, think of it like streaming things. So it's going to stream this string over to cout. It's going to stream this indicator here that this line is done, give it a new line. Now let's see how this behaves when I compile and execute. Now you can compile and run. You could compile simply and then run. Okay, so it's up to you. I can compile and run all at once. Okay, but notice that it actually ran, but I can't see it. It's too fast. So I need to do something to hold the screen. Okay, there is a function where you can actually cooperate with the operating system to let you pause this instruction. So we're going to do this. The function, by the way, is called system. And notice it's a function, right? So it has parentheses just like main. And we're going to call it pause. So that will be the argument or the parameter this function takes, which means if you're familiar with DOS, pause is a DOS command that holds the screen for you. And it will keep the prompt from not coming back until you press a key. Okay? So this will be helpful here to hold the screen for us. So let's see how it works. So I'm going to go ahead and compile and run again. And there you have it. Okay? So let me just go ahead and make this one a little bigger. I think that's as big as it will do it here for my screen. Let's see if the layout. I think that's about as big as it will get it here. That's fine. But press any key to continue right here after hello world. Hell world. Now, I recognize that this is 2020, so that probably is applicable. But let's fix it, and let's be hopeful that the remainder of 2020 will be a lot better than what we have witnessed so far. So to conclude this video, I'm going to add one more line of code here to let the operating system know this is the end of this function. Hey, when a function ends, and we're going to talk about stacks later on, we're going to talk about how memory is managed and how the processor is going to know we've reached the end of a stack properly and we've executed properly. You want a function typically to return some sort of a value to say, hey, I terminated fine. So what you need to do is you need to have main actually return an integer. So now notice the new syntax that I'm throwing in. So it is expected that main, when it finishes executing, it will return an integer. So have it return that integer. And notice 0 is an actual flag that says everything finished properly. And again, in another lesson, we get to learn how to play with this so we can handle errors to the operating systems, special cases, that sort of thing. Notice for our program, it won't make major difference from what we've seen previously. Now remember, I made some changes. So I'm going to go ahead and compile and run. So compile and run. And there you have it. Notice now it says hello world. Okay, so we're being a little optimistic. And press any key to continue is the way to go because I have a system pause there. Okay, excellent. So now if I do this, this is what happens. Now, just to show you one more thing again, can I repeat functions like system pause? Yeah, that's the idea behind functions. You can reuse them again. So let's see what is the effect of using system pause twice, or 3 times, or 4 times. So again, you need to recompile and run it again to see, or to notice the difference between this version and the previous version. So I'm going to go ahead and compile and run. And notice I have a system pause. So I'm going to hit it again. And notice now again I have a system pause running, which gives an output of press any key to continue twice, right? So because I called that function twice. Okay, so again, we're going to be seeing functions later on, right? What do they do? So we've seen 2 functions today. We've seen main and system. Okay, now if you didn't have IOStream, what would happen? So let me just put a comment on IOStream. Let me just compile here and see what happens. And I get an error for cout. Okay, so I hope everybody got the picture here. Now let's suppose I put a comment on using namespace std. So this is what I want you to do when you're done with this video and you read or replicate this code. Go ahead and experiment and see what happens if you miss a few things or you mess things up. So compile here. And notice the same thing now. Cout is out of, it's totally undeclared. You need that namespace std in there to be able to use cout. Okay? All right, so let's suppose you didn't have cout and you didn't have namespace std. So this is the kind of things I want you to experiment. Will that have any effect on system pause? Okay, so compile and notice none whatsoever. So system pause, the function itself, system, was it defined under the IOStream library? Well, let's find out. And now let me compile and see if we get an error. And sure enough. So you cannot use the function system unless you have IOStream already included and linked to your application. Okay, so I hope this little exercise, right, helps you understand what is feasible right away, how to write your first C++ program, okay? And in particular here, I'm using C++ syntax. C works pretty much the same way at this stage. Okay, so if I was writing this in C instead of IOStream, right, I would use another library like stdio.h. Okay, but the rest will be pretty much the same. Okay, except I wouldn't use cout, I would use printf. But the system pause will still be, or system with the pause as an argument, will still be valid in C as well in Windows. So again, this is okay in Windows. So because I'm in a Windows environment, even though I'm running my Windows machine as a virtual machine within my iMac, as you can see from the recording. Okay? If I were to write this in a Linux platform or by iMac, which is a Linux-based platform, this system pause will not work. So there will be other things or other ways to make the screen hold for you. Okay, so I hope this was helpful. Okay? And let's hope the second half of 2020 works out really well for all of us. Okay? And peace again. See you again.